Alright folks, welcome to yet another tutorial from the photo scanning series on creativeshrimp.com. My name is Gleb Alexandrov, and in this video we'll deal with this pretty large photoscan environment with sort of mega texture created in reality capture in Blender. It was the ruins of the Bernardine cloister in Brest, Belarus. We captured it with Pavel Konyaev about 10 years ago, and back then our capturing intuitions weren't on point. We should have probably used this pattern for shooting the corridor stuff, meaning utilizing a wide-angle lens and walking in a straight line like this. It was very far away from what we actually did. Due to having only the normal kit lenses at our disposal, with the crop sensor cameras, we did it like this. Basically, there was a lot of rotation in place, as if we were shooting panoramas, you know? And on top of that, we didn't use any type of color checker, so it's practically impossible to determine the correct white balance at this point. What we did right, though, is that we used a flash for capturing the source photos. In such darkest dungeons, even if there is some ambient light streaming in, it's advisable to use the flash indeed. Even if it's a standard on-camera flash, not a ring light or something, it still works wonders in such dusty, rough and diffuse environments like these monastery dungeons. So that was the thing that we did right in the ocean of things that went wrong. And still, despite these flaws, we got the usable coverage, almost full 360 degrees representation of this tunnel. Then I simply deleted the outliers, for example the photos that were overexposed for some reason, and the rest was quite usable. You can see a lot of panning around, like the panorama approach that is not great for photoscanning. We ended up capturing 1200 images, and you can see that we also scaled them down to 2K. Anyway, the spatial fidelity of the source footage was such that it didn't allow to realize the full potential of it, the full resolution, so scaling it down by the factor of 2 didn't make it worse, it made it better. For the processing, I set the image overlap in the alignment settings to low, to make sure we got more hits and more potential matches during the camera tracking process and creating the point cloud. Then, to make it slightly more manageable and approachable for an average computer, we halved the resolution furthermore in the image depth map calculation menu. So it's the image downscale of 2 implemented, meaning the half of the resolution of the already downscaled images. And then we could have pressed the start button, went for a coffee, but personally I prefer to do it in a step-by-step fashion, to be in control at each stage basically, and not wait too long and then see that it all exploded somehow. You can see by looking at the camera pattern that we turned around indeed. Anyway, I cleared the region right here to clear the view, so we can see it better without anything getting in our way. And in the view menu, I'm getting into the top orthographic view in order to change the ground plane orientation. Click on set ground plane. I'm trying to align the point cloud to grid, like this, in the top view, and then I'm switching to the left view, only to discover that it sits very neatly on the imaginary ground plane already. In the front view, everything looks cool to me. Now let's get back to the perspective view. Even though only 70% of the cameras got matched, I think it's a great result considering the source footage quality. So totally no complaints. I'm very happy about the reconstruction quality so far. It's pretty much a miracle that we managed to capture almost the entire surface of the corridor with just a few blind spots. Allow me to disable the cameras for a moment, so we can see the point cloud clearly. I think it has a lot of potential and will be rendered nicely. From here we can choose 2 paths. The first one would be to set the reconstruction region to encompass pretty much the entire corridor, and then export it in a quick and dirty way like this, with probably just 1 texture for simplicity's sake, and I would still apply the image downscale factor of at least 2 for mesh reconstruction. Alright, now I'll save the reconstruction region by clicking this button, create a separate folder, and let's call it complete. By doing this, we save this bounding box, which we can load up into reality capture anytime and just reconstruct everything. But next I want to shrink that box down to encompass an approximately 1/3 of a corridor, to try a different type of workflow, which is a little bit longer to set up, but is much more flexible. I'll call this part of the corridor 01, and then I'll scale it down like this and expand from this direction. I think the door frame serves as a natural junction in between different parts of the corridor, so it's perfect. I'm going to call it 02. And then we have to set up the third part, which is this slightly smaller section. So we have exported out 3 reconstruction regions, and now it's a matter of loading them up one by clicking this button, import reconstruction region, and then rendering it out. Okay, here comes the first one. As we have mentioned, for the sake of the tutorial, I'll leave the image downscale factor at 2, but if you possess some extra time and feel like your computer will handle it, feel free to use 1. No downscaling at all, except what we have done in pre-processing. I will also optimize the windows like this. Here's a quick tip: you can hold Shift and use the mouse wheel to increase or decrease the field of view. It's much more comfortable in such tight spaces when you have a xenomorph field of view, or alternatively you can try to simulate the Hitchcockian dolly zoom. That's another worthy investment of time within reality capture, I guess. Let's not forget to colorize our stuff, but first let's revisit the color and texture settings and make sure we apply no downscaling to our images before colorizing and before texturing. So that's how it looks. And all in all, I think we have covered like 90% of the surface with usable coloring, maybe except a few spots like this, which we will fix really quickly in Blender. Okay, currently our mesh looks like it was folded into this kind of manifold apple strudel. There's 22.2 million triangles worth of details. I think that's great considering the downscale of the initial footage. We can switch over to the vertices mode to see through the excessive geometry and maybe enable the type points to see the rest of the model. That still has to be reconstructed using our exported render regions. And actually, while we are at it, let's import the rest of the regions, namely the second one and the third one, and just mesh them. And even though it probably doesn't look like it takes a long time during the tutorial, it definitely does. It's at least a half an hour or an hour of processing for each chunk. I'm just making it look like it's instantaneous, which is not. Don't forget to colorize each chunk after creating the mesh. I am fast-tracking the process to not bore you to death. So here goes the third render region and the last one at the same time. Press normal detail, then colorize. The same stuff over and over again. So here we go, we have implemented the component-based, or rather the render region-based workflow to save up some memory. And even though it takes extra time to set it up, it's totally worth it in terms of optimization, in terms of how we're going to process these models in Blender later on. Hint, one by one. Especially if we're going to render them out in a game engine, for example, then it definitely is more optimal to split it like this in order to generate levels of details, and maybe so we can recombine them in different order. It's good from any perspective we can imagine. Now it's a matter of making these high poly sections of the corridor usable by creating their low poly counterparts and projecting the details. So in the tools menu it's time to find the simplify tool command. Click on the model number 1. Actually, let's name it HP meaning high poly and the respective suffix. Click on the HP_01, activate simplify, and let's choose the target triangle count. I think something like, well, maybe 70,000 triangles as opposed to 22 million would work best in this case as a nice compromise. Depending on the application, I think that should be a pretty manageable density. For Blender rendering, definitely. For the game engines as well, I believe. Mostly. The next part of the workflow will be to start reprojecting the textures. So this is our first low poly mesh, corresponding to the HP01 model. So commence the normal map displacement and albedo reprojection. But first, I would like to have a look at the unwrap settings from within the Mesh Model menu. Let's expand this tab. I would go with maximal texture count of 1 and texture resolution of 16K. It would be fairly convenient to have one texture per part, especially considering that these chunks are pretty much the same size, plus minus. You can see that the largest polygons that go beyond the threshold of 10x didn't receive the UV map, and that is exactly what we want from the perspective of saving up some UV space. Now it's time to jump back to the Reproject menu and click this button. Here's how the baked textures should look, and there are 3 of them: the diffuse texture with some shading left in it, the displacement map, which shows up as this weird colored something, and a normal map as well. That is actually more than we need. I don't think we'll make use of the displacement map, but let it be. Now this process should be extended to the second and the third parts of the model. Pretty much the same steps, just the names of the models will change, and that's it. Well, maybe the poly count could be adjusted, because these parts are pretty much the same size, but some are a little bit smaller. Okay, for reprojection, it's important to not mess up the correct source and result models from this menu. And after revising the unwrap settings, we can just say yes to everything that Reality Capture has to propose, and it most likely will be alright, and ready to be exported out from the Workflow tab. Let's go with a good old FBX format, create a separate folder for it, and export each mesh individually. One last thing to check would be texture settings, namely the resolution. I will go with a 16K TIFF texture. We can downscale it anytime we wish, but it's useful to have a source with a high textile density to work with. Alright, I think we have exported all the main parts of the corridor out, and that means that the Blender cleanup work may commence. Yoo-hoo! And our Mesh Doctor session starts with importing the object generated in Reality Capture into Blender. We use the FBX format, so let's select the FBX importer, select all 3 files and click import. Here we have it, and let's check that all textures have been imported indeed. I'm gonna go into the material preview mode to check it out. Right, it looks like the textures are in place. Now I'm gonna create 3 new collections. I'm gonna name them 01, 02, 03. And assign the model to each collection, like that, so we can work individually on every mesh. Well, despite the fact that geometry is a little bit messy right now, it's ready for interior rendering anyway, and we could have made a render if we wished to, but instead I'm gonna do some cleanup. First, I'll leave only the first model visible. I'm gonna press Tab to enter the edit mode and select the redundant faces and delete them. So C for the brush selection. We can just bulk select the faces like that, or we can select one of them and go select linked flat faces. And that will select all the faces within a certain threshold that can be adjusted. It's a fairly convenient method of expanding the selection to the faces with similar normals. And it can be complemented by the brush selection afterwards to tweak it, X to delete faces. Then I'm gonna select the bottom faces and delete them as well. And this set of faces as well. Once again, the brush selection can be invoked with a C shortcut, and fall off, or rather the size of the brush, can be adjusted with the mouse wheel. Next, we can follow up with this side of the mesh and the top one, something like that. I sped up the footage just a little bit before it got boring. I X and delete those faces. We have just this size to tweak, and then we'll move on to the Boolean tools. Okay, I searched linked flat faces from the Blender search bar. That's actually my preferable method of selecting this feature. I don't know why really. Just a matter of habit, I guess. Okay, before we carry on with cleaning up this mesh, it is important to point out what would happen if we exported it out to game engine. Right now, most of the faces are facing in towards the tunnel, and that's how we would like it to be, and we can prove it by enabling the face orientation within the viewport settings. Basically, if the face is drawn in red, it is a back face, and it most likely would be transparent in a game engine. Once again, it's totally fine in this case because it's the interior polygons that are supposed to be opaque. Alright, I think that was important to point out. For further tweaking, I would propose to use the Boolean tools. I will start off by creating a cube. This will be our cutter mesh. I'm positioning it roughly to cut away this messy part of the building. In the preferences, I'm going to go to the add-ons tab and make sure that I have the bool tool add-on enabled, which I do. With this add-on, we can apply the Boolean operations much quicker. For example, select the cutter object, then shift-click on the mesh, press Ctrl and minus on the numpad, and that will automatically assign the Boolean modifier to the mesh, switch it over to the difference mode, and pick the object that serves as the difference operand automatically. Oh, actually, it will also switch the visibility of the cutter object to bounds, or to wireframe depending on the settings. When it comes to a frequent use of booleans, this add-on is indispensable. Really, it's very convenient to do it like this. And before we have collapsed the modifier stack, we can move the cutter object interactively, which is also a very cool thing indeed. Sometimes the mesh can get pretty heavy, so the interactivity will be much less enjoyable. So if it becomes so heavy that Blender starts to have performance issues. But anyway, we have such possibility. Here I'm cutting the door frame really accurately. You can already tell that the model gets much more clean. No more hellish candy floss of polygons all around the place. That's already something. I added yet another cube to adjust this door frame on the other side. And I think we're pretty much ready with this mesh. We just have to do something with an opening in the ceiling, because that's the most problematic area of this model, I think. And at any point we can go right-click, convert to mesh, and that will collapse the modifier stack and make all the Boolean objects obsolete so they can delete it. It's useful if there are some performance issues or maybe the viewport gets a little bit too cluttered for your taste and you want to free it up. So from time to time, the modifiers can be applied. It's a pretty useful trick. Or they can be applied manually from the modifiers menu. But if there are more than, let's say, 5, then it makes sense to just collapse the mesh. Then I'm grabbing the lonely floating areas of faces with the help of the L shortcut to select linked. We can press the shortcut simply on hovering over these areas. And then I feel that this part needs some love too. And as we have mentioned, the ceiling, the hole in the ceiling. I think the cube positioned like this will serve as a nice Boolean object. So shift click on the main mesh with this one selected and Ctrl minus to add the Boolean subtraction modifier, tweaking it after the fact ever so slightly, and I think that all modifiers can be applied at this point. So we have cleared up the first part of the mesh, the first part of the corridor. There are 2 more to go. But first, there are still a few texturing issues with this model that we can take a look at. Let me enter the dungeon with the help of the Shift and X Engrave shortcut for the first person view. Sorry about the W's. So here we have a problem, and this part of the wall is a little bit too blurry. We can fix it. Not that it will be seen in the final render, it won't, but still I feel that it's a worthy exercise. So let's open the shader editor first, and make the material shadeless by connecting the diffuse texture right into this surface input of the material. It makes sense from the perspective of tweaking the albedo or the diffuse texture alone without meddling with other properties of the shader. I've also switched the view transform of the color management to standard. That is needed for texture projection that we're gonna do in just a second. So let's say we have this pretty badly textured part of the wall. What can we do? Let's try projection. Firstly, we need a camera, so I created one, then pressed Ctrl Alt and 0 on the numpad to make it an active camera and align it to the view. Let's make it a square ratio, 2K resolution to have enough pixels to work with. Then we need to render it out and save it as an uncompressed format like PNG. So image, save as. I'll create a separate folder for it called projection. And I'll call this one fix_01. And I will open it in GIMP. You can use any image editing application that you like. Okay, and now we can do whatever we like. We can paint on top of it, drag images from internet and overlay it. Or alternatively, I will just create a new layer. By default, it's created as a fully transparent layer, and that's exactly what we need. We're gonna paint on this transparency, or rather use the clone brush to clone some parts of the original image to cover the blurriness. Something like that. Make sure you have the simple merged checkbox enabled if you use the transparent layer for cloning. What I'm doing here is probably not the best showcase of the technique, because we could have used any type of external sources for overlaying and stuff like that. But anyway, I'm going to export as to save the transparent layer with the fixes we made. Let's call it fix_01b. Export it out as one of the formats with transparency, preferably uncompressed. PNGs or TIFFs come to mind. And once we've done it, it's time to get back to Blender. We need to import this image into image editor. So let me create a new window. We can press Shift F10 or open the image editor from this menu. And I think I'll just grab this and move over here. So we have our image meant for projection imported. Now we need to apply it. I selected the object, went into the texture paint menu. Oh, actually the diffuse texture layout got open automatically. That's very convenient. Thank you so much, Blender. Now we can go over to the tools menu at the top, and then into the options tab, external, and click apply. Oh, actually we need to click apply camera image instead. I remember it has the in the name, so it must be this file. Yeah, we applied the projection as you see here. I will press Ctrl Z to revert it and Ctrl Shift Z to bring it back, so we can see how it changed the look of the texture. Alright, awesome. What other techniques we could have used to eliminate the problem of missing texture data? We could have used the clone brush, obviously. This part seems to be awesome for testing, so let's get back into the texture paint mode, select the clone brush, place the 3D cursor to the region that we want to sample for the clone brush, and let's gradually inpaint this guy. Currently, the clone brush works in the screen space, so if you want to clone the parts of the texture without the distortion associated with perspective, you would need to do some work around. But first, a quick digression. I'm starting to feel claustrophobic. Maybe reducing the focal length would help, just like we did in reality capture, the xenomorph vision. So jumping into the edit mode, selecting this portion of polygons, Shift D to duplicate, R to rotate, so it's roughly in the same orientation as the floor. Don't separate it though, it needs to be a part of the same mesh. Back into the texturing mode, now the clone brush would work perfectly fine because this object is in the same orientation as the floor, so to speak, or in other words, its normals face the same direction. So that is a quick tip that hopefully expands the usability of the clone brush in Blender. So we have covered this untextured part with something, and now we can just jump back into the edit mode and delete this temporary canvas. L to select all polygons, like this. X, delete all vertices. After doing the texture fixing work, we have to restore the connections in the shader. So back to the shader editor. I'm dragging the BSDF output into the surface input of the material. As a quick refresher, in addition to the diffuse texture, we have the normal map that we generated in Reality Capture and that stores the geometrical details. The color space for it should be non-color or linear. I think it all looks great, really. Now fast tracking forward to not torture you too much with the mesh cleanup work, but basically to recap some steps, what we need to do with the second and the third section of the corridor is the same process, really. The few useful tools that we have already explored would be the Select Linked Flat Faces tool, the brush selection, which can be invoked with the pressing of the C shortcut. The goal with the second and the third sections of the corridor would be just like that, get rid of the faces that are making it look like an apple pie, these redundant faces that need to be trimmed with the help of the standard modeling tools, or the Boolean operations. That, in my opinion, is probably the fastest way and the cleanest way to get rid of the unnecessary faces. As we have proven before, the worthy finishing touch would be to convert everything to mesh, and then to fix those parts of the texture that haven't received much data during reconstruction. For this, the clone brush and projections may come in handy, though feel free to start with the clone brush because it's slightly more intuitive. So that's the process of mesh doctoring the low poly model originated in Reality Capture after we have baked the textures from the high poly version of it. Finally, after making changes to any textures and quitting Blender, don't forget to press the save button. Thank you for watching. My name is Gleb Alexandrov and you have watched the tutorial on creating the larger environment from photoscan data. What we managed to do throughout this tutorial together is taking this pretty large environment scan made in Reality Capture, splitting it in three parts, three sections of a corridor, reprojecting the high poly details, then cleaning up the mesh so it can be used in game engines or for renderings, animations, whatever you want. It can be used in any kind of production, and we can't wait to see what you will do with it.